Hello.
Yeah, sure. Okay, so welcome all to today's session on application of R programming in biotechnology. So it will be a hands-on session. Hope you all have downloaded the required software. Okay, so today I'll be covering these topics. Firstly, I'll be introducing our language to you all, what are all its features, and then I'll be explaining our studio, what are all the different the features available on the software, and then I'll be briefly explaining about variables, what are the different operators, and then what are the ways of importing and exporting files, how to install the packages, and how to use the help function. Apart from that, we'll also see how to plot various graphs and how to save them for publications. And also, I'll be explaining a couple of examples that we can use in our bioinformatics. So, firstly, let's understand what is R, okay? Basically, it's a programming language that was developed by Ross Ihaka and Robert Gentleman in 1993. So, it is used mainly for statistics and data analysis. So some of the features that makes this language very popular is that it is very simple. As we all know, even those who are new to this can also easily learn it as it has simple syntax similar to that of English language. And also it is free to download as it's an open source and it is platform independent. It can be downloaded on various platforms like Windows, Mac, and Linux. It is portable as we can write code from one platform and it can also be run on other platforms. And it is interpretable language, meaning that the code can be executed as soon as it is written. Thereby, we can make the development cycles very quick. So let's understand now what is RStudio. Basically, it allows the users to run the R in a more user-friendly environment. This is a free tool that you can download from this particular website, that is rstudio.com. So here, as I can I've displayed you a screenshot over here where you can see that the left hand side is a console window where we can type our commands and see the output. On the right hand side we can see the workspace area which will show all the active objects. Okay, and second tab is here history that will give the list of commands that you have used so far in the session. Below you can see the files tab where we can see the files and folders that are present in the default workspace. Second is the plots window that we can see graphs if we have any generated. Third is the packages tab, which will give you the series of packages that are available. And then last one is the help tab. So now let's understand what is a variable. So basically a variable is nothing but a storage container that stores values. So a valid variable name can consist of letters, numbers, and the dot or underline characters. So it usually begins with a letter but not with digits. For example, a valid variable name could be like this var underscore name. However, you cannot start with a digit such as this 2 var underscore name. This is considered as invalid. So kindly, whenever you are writing any variables, make sure that it starts with letters. Okay. Next, let's see how we can assign values to these variables. We can do so using an assignment operator, that is using this symbol, left hand symbol that you can see over here. Okay, so let's move on to the RStudio window here. Okay, so here this is considered as a script window where we can write the script, edit, and save it for future use. Okay, so firstly let's understand which is the working directory that we are currently having. So for that you can type in get wd open and close bracket and see which is the default directory over here. So I hope all of you are all trying it side by side. Can anybody confirm that you guys are also trying side by side, or can I go ahead? Okay, so this is how you can see. Okay, so this is how you can see which is your default working directory. Suppose if you want to set your working directory to the folder where all your files are there, then you can go here session, then set working directory, then choose directory. Okay, so in my case I'm going to choose this. So your working directory has been changed now. All right. So here right hand side you can see list of default packages that the R software has provided. Okay, so for example, if you click on them, the corresponding library gets uploaded. Suppose if you want to install a new package, then you can go over here and click on the install tab and choose the package that you wish to install. Okay, say for example, this is just an example I'm showing you. You can do so according to your requirements.
Meanwhile, ma'am, there's a question by Mr. Soumya Ranjan.
Mm.
What is the need of installing this package?
See, some of them are by default given, but for certain, say, operations to be performed, you need to install a certain package. Everything will not be provided as you just download it from the R website. So each package has its own set of functions. Okay, say for example, if you want to read an Excel file, you need to download a separate package for that Excel function. Likewise.
Another question we have is by Mr. Thamini, and it is, what is library?
So basically, it includes set of modules, okay, wherein all the particular functions and operations would be pertaining to that particular, domain would be installed in that, and you can perform. Say, for example, if you want to perform anything related to Excel, then you have to load that particular library. Then only you can perform the read and write functions. Otherwise, you can't. So suppose if you want to stop, you can click on this red button. Okay, so let's move on. Let's understand about operators now. So basically, they are used to perform operations on values and variables. Okay, so today let's understand different arithmetic operators. So firstly, we will see how to assign values. So here x assignment operator followed by 6. So that means 6, that is the value, is being assigned to the variable x. Similarly, 2 is being assigned to y. So when you perform addition 6 plus y, it will give us the corresponding output. So you can click on here run. So you'll get the output here in the console. Okay. Next, similarly, we can perform the subtraction over here. Right. Next is the multiplication in a similar fashion, and then division. So basically, this asterisk symbol is for commenting purpose, meaning if you have anything to write or explain anything, then you can write it in this particular way. Then we'll see how to write an R program to get the input from the user. So for that, you need to write uh, var1, that is variable 1 equal to read line. In the parenthesis, you need to write enter the first number, so that when you execute this, it will ask the user to give the first number, and so on. For four different numbers, it will ask the user to give the input. Later on, it will convert them into the integer, and then perform sum of all the four numbers and then give the output. So here enter the first number, so I will give it as say 10. Next 20, 30, 40. Now let's print the output. So we got the output like this. So there are different ways. Okay, you can get the input from the user itself, or you can also manually give it through the assignment operator. Okay, so let's move on to the next data type, that is a vector. Vector is nothing but a sequence of elements all belonging to the same type. Okay, so for example, this is an integer vector. So here we are giving a sequence of numbers, say 1 2 3 4 5 6, to a variable called x. So since there are multiple elements, we have to give c as the prefix before the parenthesis. Okay, similarly for character vector, the syntax is also same, but you have to give in double quotes whatever the values you want to give. So now if you see in the console, you can see what are all the values that you have entered in the integer vector. Similarly, if we see for character vector what we have stored, we can get all those values here. Okay, so now let's see how we can generate a vector for a series of numbers 1 to 10 using a sequence operator. So for that, you need to just write 1 is to 10. Okay, so here we got all from 1 to 10. Suppose if you want to get a series of numbers from 1 to 10 with a gap of 2, then you need to use this particular syntax, that is seek in the bracket from which number you want to start 1 to which number you want to end by is the step size, that is 2. So now you got 1 3 5 7 9. All right, now let's see how we can name the vector. Okay, so for that, we have to first write v, that is the variable name, and then assignment operator, then c. Then first we will write what is the name that you wish to assign. I'm giving it as a, that you write in double quotes, equal to apple, that is the value name. Similarly b, value name is banana, c, cherry. So let's execute this. So this is how we can see it in the final outcome. Okay, now let's write the same way using the names function, how we can assign the names. See, earlier we had created this way. Now if you want to write the names of them separately, see, there are two ways of naming it. Either you can use directly like this, or you can write it in a separate line as this. Both give us the same. It all depends on your convenience. Okay, now let's see how we can extract a specific value from the vector. For example, consider the following example. Assignment operator C. In that I have stored A, B, C, D, E, F. Now if I want to select only the third element, Then I need to write v in the square bracket, that element number, that is 3. Okay, see, now we got like this. Similarly, if you want to access fifth element, we have to write like this. Okay, suppose there is a situation wherein you have to select first, third, fifth, and sixth, then you can write like this also. V is the variable name, square bracket. C, because we are gonna, want to select more than one. That's why first, third, fifth, sixth element, all we want together. So we are writing in this fashion. Suppose you don't want the first element, but you want the rest of the elements. In that situation, you can use the negative symbol. So V square bracket minus 1 means you're telling the system to omit the first element. So we got B, C, D, F here. Okay. Hello, am I not audible? Okay, so can I continue, or are you people also doing it?
Yes, ma'am, we have an image by Dr. Soumya Ranjan.
Now, what does it say?
Uh, there is an error he's facing. You may check it once if you can.
Can I look into it later in the?
Yeah, sure. You can look after the end of this session.
Yeah, yeah, sure.
Yeah. Is it okay, Dr. Ranjan?
So, anyways, guys, the recording will be provided. So later also you can try all this. Okay, so till here we saw. Now let's move ahead. Okay, now let's see how we can modify the existing vector elements. Okay, so for this, first what you need to do is you need to first identify which element you want to edit. In my example, say for example here, I want to change this particular third element into k. So for that, I need to write like this: v square brackets 3, and then I'm assigning to that a new value, that is k. So when you execute this, so now you can see that it has been replaced with k. Okay, now say we have three different vectors and we need to combine them into a single one. So that is also possible. Say for example here we have a first vector consisting of elements 1, 2, 3. Okay, and then there is a second vector consisting of elements 4, 5, 6. Third one having 7, 8, 9. Now let's combine them. See, now we got a single one having all three vectors. Now let's perform some of the arithmetic operations on two vectors. Okay, say I have two vectors. In V1 I have 11, 12, 13, 14, 15. V2 I have 1, 2, 3, 4, 5. So if I need to perform addition, you need to just write V1 plus V2. Okay, and similarly if you have to do subtraction, then you have to do V1 minus V2. For multiplication, you may have to use V1 star V2. For performing division operation, you have to do V1 slash V2. So let's see now all of these together. Okay, next. Say suppose I want to find out a square root. Then that is also possible. For that, you have to use a square root function. In the bracket, you need to write the vector variable name. And also some of us might have a situation wherein we need to calculate mean, median and all. So that is also possible here. So say for example, have this particular vector, say v is equal to 1 2 3 4 5 6. Now for that I have to find out the mean. For that you need to write a mean function. In the bracket you need to mention the vector name, that is v. Okay, so in my case, when I do this, so I get the value is 3.5. Similarly for median also you can have a function. Okay, and then for standard deviation it is SD followed by the vector name. And similarly for variance the function name is VAR, and then in the bracket you have to write the vector name, that is V. Okay, so let's move on to the next data type, that is called list. So are you guys able to follow till here?
Hello everyone, I want you to be very interactive. I see only two or three people responding. If you'll be interactive, we can proceed faster.
Sure, great. Okay, so the next one that we are going to focus is on the lists. So basically lists can store multiple types of values at once. Okay, so here we can see that uh, there are different types of lists. Integer list is there, character list. Suppose if you want to create a list, consisting of mixed data types, that is consisting of both numbers as well as characters, that is also possible in this case. Okay, so for example, we will go to the first one, the integer list. For that, LST is my variable name. Then I'm using an assignment operator. Then I'm giving list function. In that bracket, I'm giving the element names 1, 2, 3. Okay. Similarly for character list, you have to do the same, but here you need to write the values in double quotes. Okay. Now let's understand the contents of this list using the structure function. So here we can see that the first element of the list is a number, second one is a character, third one is again a number, and the last one is a logical value. So this str gives the structure of that list. Next, let's see how to extract the specific element from the list using square brackets. Guys, am I going very fast or is this speed okay? Okay, great. Okay, fine. So we have covered up to here. Now, let's see if I want to extract a particular element, say the second element in that list, how we can do so. So for that, you need to write LST, that is the list name, and in the square bracket, the number of the element that you wish to retrieve. So I wrote list bracket 2, so the second element is ABC. Similarly, if I want first, third, and fifth element, in that case, you need to just write the numbers, that is 1, 3, and 5, the elements that you wish to retrieve, prefix C, and before that, the name of the list. Now, if I want to add elements to the existing list, we can do so using the append function. Say, for example, I have one new list, okay, and then I want to append one element into it. So, for that, you can try this. So, now ABC have been appended to the previous list, that is 1, 2, 3. Okay. Now, if I want to remove an element from a list, for that you have to write null, and you have to assign that to a particular element of that list. Say, for example, I want to remove this C value from that list. That is the third element in that. So for that, you need to write list bracket third element, and then for that, you need to assign value null. Okay. So let's run this now. Okay. And let's see what we have. See now, C is removed. Okay, so the next one is, suppose if we have multiple lists, how do we combine them? So for doing so, we can use the C uh, parenthesis, okay, for combining purpose. Say I have two lists now, ABC character list and an integer list. Now I need to combine both of them, for which I can use this particular C in the bracket, the list 1 name and the list 2 name. So now we have all combined. Suppose you want to identify what is the length of the list, means how many elements are there. For that, again, you have to use a function called length. Length, in the parenthesis, you need to write the name of the list. So it is giving us 4 elements are present. Okay, so this is done. So next data type is matrix. Okay, so matrix is nothing but collection of elements all of same type. Okay, it is arranged in a two-dimensional layout. So that is basically you can create a matrix using the matrix function. That is, first you have to write a variable to which you want to assign the matrix, then assignment operator, then you have to write a matrix function, means matrix, open and closing brackets. Here I'm going to write values 1 to 6, and then number of rows is 2, and number of columns is 3. Yes, someone was talking now. Okay, so this is how we create a numeric matrix. So let's see down how it comes. See, it gives us the display like this. And now similarly, let's create a character matrix. Okay, so for that, I'm taking a new variable called letters. I'm assigning A, B, C, D, E, F values. Okay, and then I'm creating a matrix function. Here I'm giving that variable letters for, and the value should be represented in the form of 2 rows and 3 columns. Hence, this particular number I've mentioned. So here we can see the output coming in this fashion. Okay. Suppose if you want to see what are the dimensions of the matrix, for that you need to use dim bracket name of the matrix. So now you see 2, 3. 2 represents rows, 3 represents number of column. Suppose if you want to make it 3 by 2 matrix, then what you need to do is you have to take this dim variable, and to that you need to assign 3 comma 2. So it will do uh, what you say transpose of it and gives you the matrix. Now let's assign some names to it. Okay, so for that you have to use row names bracket m, means for that particular matrix what the row name should be, you're assigning it as r1 comma r2. Okay, similarly I want to give column names. For that you have to use col names bracket whatever the matrix name is, and then for that you are assigning the value c1 c2 c3, and then let's see how the outcome displays. See now, so here we can see the names have been displayed. Now if you want to extract a specific element from a specific position, for that what you can do is you have to use this m square bracket 2 comma, and then you have to leave it blank, means I want only the second row elements. So I got like this 246. Okay, so I hope I'm clear up till now. If there is anything, do let me know. I'll answer it towards the end of the session. Okay, so let's move ahead now. The next type is the data frame. So basically this is nothing but a table in the form of rows and columns. Okay, it is similar to how your Excel table looks like. So let's create a data frame to store employee records. Okay, so here I've considered a name as a variable and I've given values as Bob, Max, and Sam. And second column I've considered as age and I've given values as 25, 26, 33. And similarly, third column is city and I've considered variable names as these. So for creating a data frame, you need to use a data.frame function, and in the bracket you need to assign all these variable names, that is name, age, city. Okay, so when we execute this particular set of statements, this is how we can see the output. Suppose if you want to look at it in the table fashion, you have to use view command, type VIEW with a capital view and the name of the data frame. So here you can see. Is anyone else also trying on the system? Do I have to wait? What about others? All right. Okay. So let's understand now. Suppose if I want to retrieve only the first column, okay, how do we do that? So for that, again, we need to use data frame name, that is in my case it is df, and then in the square bracket you need to write the first column, that is 1. So here we got the values of only the name. Okay, suppose say I want to edit a data frame. That is also possible. For doing so, we have to use edit function. So let's try that. So here it will give you a user interface where you can add values if you wish to, and then close it. So automatically that value gets appended. Okay, now let's try to sort this by age column. So in R, by default, sorting is done in ascending order. Okay, so for that, what you have to do is you have to write the data frame name. Then you have to, in the square brackets, you need to mention order, that is the order function. In the parentheses, you need to write a data frame name. In my case, it is df, and dollar symbol is inside the data frame, which column I need to access. So hence age. Age is the column that I want to sort. That's why. And then comma. So see here, everything has been assigned. Here you can see that each column has been sorted. Suppose if you want to sort it in descending order, then you have to write minus sign over here. Then the system will understand that it has to be in descending order. Alright, so let's now look into how to save this into an Excel file. Okay, for that here you have to use a library called OpenXLSX. Sometimes it will not be there on your system, so in that case you need to go here, click on install. Okay, here you have to type this and you have to click on install. Okay, and then before using it you need to write as library followed by that particular library name. You can either do it like this by manually typing, or you can select over here and do the tick mark. It will automatically get uploaded here. Both the ways are fine. Okay, and then to save it you have to use write.xlsx, that is the command, and in the brackets you need to write the data frame name that you wish to save, comma file is equal to, in the double quotes you have to write the name that you wish the name of the file to be saved as. Okay, so after which when you go to your working directory you can see that file over here. Okay, so it has been saved. Similarly, if you want it to be done in a CSV, then also you have to use write.csv as the name of the function, and then you have to write the data frame name, and then whatever the name that you wish to store it as, dot csv, that is the extension in double quotes. Okay, because mine is already open, hence it is showing like that. So this is the file. So now let's move on. Let's see how we can read a particular CSV file, meaning how to open. Okay, so for that what you have to do is you have to use read.csv function. Inside that you need to write the path. Since I've already set my working directory, I'm just giving the file name over here directly. That is my data.csv. See here, you can visualize the data over here. Suppose if you want it to be in a table format, then you can write it as view followed by your object name, that is my data. See, this is also another way of viewing it. So I hope you guys are understanding so far whatever has been taught. Please let me know if you have any queries. I'll answer towards the end of the session. All right. And please make a note of all the things that you're learning. So are you all able to understand till here, or do you want me to explain anything?
Ma'am, hello.
Yeah, yeah.
There is a question by Mr. Neeraj. What is the use of blank spaces? I mean, are blank spaces in R programming considered as spaces, or are they only to make the code look pretty? I mean, yeah.
Yeah, yeah, second one.
Okay, so they are only to make the code look better. I mean,
Yes,
clean
yes.
and proper.
Hmm.
Okay.
Okay. So say suppose you're having a worksheet in which, say suppose you're having a workbook, okay, Excel workbook, and there are multiple sheets. So how do you read a particular sheet? For that, what you need to do is you have to install a package called xlsx. Okay, after which you need to write a particular what do you say, statement, wherein read underscore excel is the command. In the brackets you need to mention the file name, comma sheet number, comma call names equal to true, means you want the column headings also to be displayed. Okay, so in my case there's some R Java issue, so system configuration issues there, but in your case it might be working. Anyway, let's move on to the graphs, which is very interesting. So I'm considering one inbuilt data set called the pressure data set. Okay. So if you want to read about that data set, you can just go to help. Here, click on pressure. So here, this particular data set gives us the relation between the temperature and the vapor pressure of mercury. So this is just an inbuilt data set I'm considering for plotting the graph. You can do it for your own data set as well later on. Okay, so for that what you need to do is, first I need to load this data set that is inbuilt. For this purpose I'm using data, in the bracket I'm writing the pressure double quotes, that is the name of the data set. Okay, and then if I want to visualize how the data looks for the first 5 rows, for that I need to write head in the brackets the data set name. So here we can see the temperature first few values and pressure first few values. These are the values that are in the data set. So in total, there are 19 observations for these two particular variables, temperature and pressure. Okay. Suppose if I want to see the plot, that is, I want to plot temperature versus pressure and see how the variables are distributed. So in that case, you can use plot function in the bracket, the dataset name. See, you can visualize it in this way. So here you can do zoom if you want a bigger size. Okay, and then you can export it as an image file or in a PDF file, whichever is required to you, and then you can delete it as well. So guys, we'll take a small break now and then we'll resume after a few minutes. I hope that's okay. All right. So we'll take 5-10 minutes break and then we'll resume back.
So we'll be starting at 5 sharp. Please be ready. Okay, before starting, can we answer some questions, ma'am?
Yeah, yeah, sure.
So I'm quoting a question. If
Hmm.
I have to do manipulation on the Excel file already saved, then what to do?
Like what kind of manipulation you want to do?
Sir, can you please unmute yourselves and let us know? Hello. Okay, let's move on to next
Yeah.
question then. Uh, how can we save files in PDF format?
Save images in PDF now.
Yeah.
So here, if you go here, export option is there. Click on save as PDF. So here you can save it.
Okay. Next up we have, is it possible to show how to import Excel file one more time, please?
Sure. So here, go to file, import dataset from Excel. Okay. Here you have to browse your file.
Okay, so I guess we can also use this to manipulate existing Excel file, right?
Yes,
This will be
yes.
the answer for that.
Yeah, yeah.
Yeah. Okay.
Okay, let's move on with the graphs. This is very interesting. You people also should try it. Okay, so now using the plot function, let's try to change the shape of the points now. For which I'm using the plot function once again. In the bracket, I'm giving the dataset name, that is the pressure, followed by PCH, that is the argument name for the point shape, and 17 is the number of the shape number I'm giving. See, there are different shapes associated for different numbers. You can keep doing trial and error from starting number from 1 to 25. Okay, see if I want, I can try something as 16 and see what is the shape I'm getting. I'm getting circular. Earlier I was getting 17 as triangular. So do try on your end. I'll wait couple of minutes. Okay, so now if I want to color the shapes, for that I have to use COL as the parameter equal to, and in the bracket and in the double quotes the name of the color. So now you can see they have turned blue. So there are different colors. Okay, you can explore. Say for example, if I want to know what are the preset colors that are available in R, you can type colors, open and close parenthesis. See here you can see the names of different colors available. In that you can choose whichever you like, and then you can plot accordingly. Okay, so I hope you're also doing. I'll give you a couple of minutes to play around with these colors. Okay, so now let's see how we can change the type of the plot that we have drawn. Okay, say suppose if I want to change this to a line plot, for that I have to use a parameter called type equal to, in the double quotes I have to write as L. Okay, similarly if you want both the line and the points to be displayed, then you have to use a argument called type equal to B. So now you can see both points and the line. Okay, suppose I want to give title to this graph. What is the main title, what is x-axis, what is y-axis. So for that I have to use main as the argument name equal to the title of the graph, then x lab is x-axis name equal to, in the double quotes you have to write the x-axis label. Similarly y lab equal to, in the double quotes, the y-axis title. All right, now let's add a legend. For that what you have to do is you have to use a legend function, and then where you have to position it. I'm going to put it in top left, so write that in the double quotes top left, that is the first parameter. Then I'm going to use here two plot here two lines. Okay, so that it will be easy to differentiate and writing a legend. So earlier in the first plot we have seen temperature versus pressure. Now what I'm going to do is in the same plot I'm going to plot another line with half of the temperature versus pressure. So let's see how it looks. So it comes like this. Suppose if you don't want the legend to be here, if you want it to be placed, say here on the top right, then you have to change it here. Then click on run. See, now it got changed to here. Suppose if you want it to be placed in the bottom, then same you have to change here. Okay. Now by default, RStudio sets the x-axis and y-axis scales automatically to best fit the points. Suppose if you want to change the points manually, that is also possible. For that you have to use an argument called ylim, and you have to specify the starting and the ending um, numbers in the axis, and x limit is the range from 0 to 500 that you want to keep the range for x-axis. So this is optional, so you don't have to take it seriously, because the RStudio itself performs automatic scaling. So in case if you want to manually do it, then this is also one of the way of doing it. All right, so now let's try to save the plot. Okay, for that what you have to do is you have to write png in the bracket. You have to write file name equal to whatever the name you want to give, dot png extension, the width and the height, and then you have to write the plot function, all that we saw in the above same steps. You need to write the dataset name, the color, point type, I want only the points, and then the title, x-axis, y-axis, and then you're telling it to close after saving. So now the file is saved. Let's go and see in the working directory. So you get something like this. Okay. So do you guys want to try? I'll give you 5 minutes. Please do this as well.
Hello everyone, I request you to please interact. Please let the trainer know if you are following her, or if you are not following, you may type in the chat box that please proceed so that we can proceed further.
Okay, let's move on for the bar graph. So bar graph we are using for knowing the distribution of various categories. Say for example, there is a fruit vendor. Okay, so he has got, he has sold 40 apples, 15 kiwis, 30 grapes, 50 bananas, 20 pears, and 35 oranges. So he wants to know which of the fruits have got sold maximum. So for that, we are gonna see bar graph and try to analyze it. So I'm going to use a variable called s. In that I'm going to store all the variables and their values like this, and then I'm going to plot the bar graph. For this, the function is bar plot. In the bracket you need to write the vector that you have created, that is s, followed by col, that is the color name, equal to whatever color you wish to see it in. I'm using blue. So here we can see that the fruit banana has undergone maximum sales here. Similarly, if I want to plot a horizontal bar graph, for that what you have to use is you have to use a parameter called horis equal to true. Okay, and las equal to 1 is nothing but the orientation of the labels. See? So I hope you guys are liking this. Please respond in the chat window. These are very good for visualization purpose, and you can use it in your report, theses, or research articles. Yeah, definitely you can use for statistics. All right. Okay, let's go on to the next one, that is the scatter plot. Okay, so basically this scatter plot here we are using it finding to find the correlation between the two variables. So for this I'm considering a built-in dataset called iris flower dataset as an example. So it consists of 150 observations on three species of iris flower: Sentosa, versicolor, and virginica. Okay, and it has four attributes, namely petal length, petal width, sepal length, and sepal width. So let's see how the file looks like. So here you can see this is how the data looks like. The first column is sepal length, sepal width, petal length, and petal width, and last one is a species. So if I want to plot petal length versus petal width and see the correlation, then you have to use this particular command, that is plot function. Then the data set name is iris, and dollar symbol means inside that I have to access the first column, the column name petal dot length, comma iris dollar petal dot width. See, now we can see the graph. Okay, similarly if I want to change the shape of the point, then that is also possible. For that you have to use pch equal to 16 and cx equal to zero point 0.6 for the size of the points. Okay, so please also do hands-on on your side. Try to, increase and decrease these values and see how the results are varying. I'll give you a few minutes for that, and you type in the chat window once you're done. Okay, so let's move ahead. So if I want to change the color of the symbols to the blue, again I have to use a parameter called color, COL, equal to, in the double quotes, the name of the color. See now, it is changed. Okay. Suppose if I want to add title and the label to x and y axis, then you have to use main parameter equal to the name of the graph, x lab and y lab parameters. Okay, so now you got the heading as well as x and y axis label. So I hope I'm clear till here. Also, we'll be sharing the recorded sessions, so you can do it later as well and let us know if you have any query. Also, okay, we will be able to answer them later on. So, shall we proceed to the next topic? Others also please write yes or no so that we can move ahead. Otherwise, we'll be stuck. Okay. Okay, so the next part is how we can use this R to, kind of retrieve sequences in FASTA format using our interest package. So this is one of the interesting usage that we all use it in our day-to-day life. I'm sure it will be useful for you also. Okay, so for this, the name of the package that is required is R-interest. So basically, this particular package helps us to create direct access to interest database. Okay, from where we can download our data. So first, let's uh, install it. For that, install our packages is the command. In the bracket, in the double quotes, you have to write the name of the package. If you are not sure about the command, you can also do it here. Go to package, install, and type over here. Okay, it will download. And then to upload it, you have to use library. In the bracket, you have to write the name of the package that you have downloaded. Okay. And then now I'm for this session, I'm trying to consider an example of a lizard sequence. Okay. So for that, what is the command that we are using is, first you have to write the variable in which you want to store it, assignment operator. Then in the double quotes, you have to write the organism name, and that would be a character vector. Okay. So here the nucleotide database parameter that we are going to give is NUC core, and ret max denotes the maximum number of sequences to download. So in the next line, what we're going to write is, I'm going to consider another variable, and then I'm going to search the interest database. For that, command is interest underscore search. Then DB is the database name, is that is NU core, means it will search the nucleotide database, and the term it is going to search is the reserved, and ret max is it's going to retrieve 40 sequences. Okay. And these are the IDs, corresponding IDs that it has taken. Okay. Now we need to fetch their FASTA sequence. For that, what we have to use is interest underscore fetch. Okay, in that the first parameter is DB. In the double quotes, you have to write as NUC core for accessing nucleotide database, followed by ID that is equal to reserved underscore search dollar IDs. That is what we have stored all the nucleotide IDs in the above statements, and then read type is equal to FASTA. Okay, let's do this. Okay, so we have got all of this here. Now I need to write it in a file. For that, what we have to do is write in that function, you have to mention the object in which the sequences have got stored, that is lizard underscore seeks, and followed by the name of the FASTA that you used to store the output file. That is liz1.fasta is the name of the FASTA file in which I'm storing all the sequences. And then sep equal to slash n means that is nothing but a new line separator. That's it. So once this is done and execute that, we will get the output liz1.fasta. So let's see how that looks like. See, this is how it looks. So isn't this easy? So I hope you all have understood till here and everything is clear. Please do try out at your end and let me know.
Ma'am, there are two questions.
Hmm.
Is it like Blast?
No, no, this is FASTA sequence. We are just retrieving the FASTA sequences, right, from the database.
And the second one is, so would this fetch whole genome or a specific gene sequence can be fetched?
See, right now in this use case, I have done for 40 sequences for a particular organism. So you can do according to your needs.
So basically, we can fetch all genes in a single organisms also, right?
Yeah, yeah.
Yeah.
See, usually how do we do it? We go to NCBI, there we manually download it, right? So instead of that, this is another easy approach.
Ma'am, there's another question. Could you please show any one example for any single gene, please?
Okay. Okay, so I'll consider one example. Say, for example, there is this um, cytochrome B sequence gene, okay, in one of the lizard. So I'm going to show that you can use it accordingly as per your requirement in your use case, okay? So likewise, you can do here. So this is the statement that you need to mention. You have to write the organism name and followed by the gene name. Then other rest of the statements would be the same. Okay. Okay, so I hope you guys are fine till here. Can we go ahead? Okay, great. If you want, I'll give you a few more minutes. You can try it from your side, all the graphs and all that I have been taught so far. Okay, I'll give you 5 minutes. Please go through all that and try graphs also from your side and let me know if there is anything that I can help with. Guys, I would like to inform you all there is an upcoming course on R programming on LiveGen Bio website available. Please go through that. And I would like to inform you all that we'll be covering all aspects of R programming and different case studies pertaining to microarray data analysis, RNA-seq, and various aspects starting from beginners level to advanced level. And also in the end, we'll be giving a lot of assignments and certificates along with career counseling. So please make use of that. So don't forget to check out that on website today.
Hello everyone, this is Ritisha. Guys, you can unmute your mic and you can tell about the course, like today's workshop. How was it? Were you able to learn something? And you can tell about the feedback if you want to like unmute yourself and talk. So let's talk for this 5 to 6 minutes. I hope people are not slept. I hope everyone attended workshop very carefully. Everyone will be getting the recordings and certificates in upcoming 5 to 6 days. So no need to worry about recording and certificates. We will be providing you with both. So apart from conducting all these workshops, there are various other workshops going on, like which we will be starting soon. Like one is of our programming. One we will be conducting on the upcoming Sunday, which will be on bioinformatics, like from basics to advanced. People who really do not know about bioinformatics, its scopes, what about transcriptomics, genomics, like we will try to cover as much as possible. But it is going to be a brief overview. Like it is going to be a webinar. It's not going to be a workshop. And after this week, we will be conducting the workshops on the same, like on cancer genomics, on proteomics, so that you can get to learn. So it will be a hands-on workshop. So just stay in the Telegram group. As I said earlier in the last workshop, just stay in the Telegram group because we will be giving offers to the people who are already in the Telegram group. Else, if if you just leave the group, you won't be able to avail the offer. Just stay over there. And I hope every one of you liked this session. And I hope no one just slept. So whatever the feedbacks are, and we will also be forwarding a Google form for the feedback. So just state your name very clearly so that those names will be used in your certificates. And then there are no corrections in the certificates. Just make sure the names you have written on the Google Forms are completely correct. Like there must not be any spelling errors. Thank you, guys.
Thank you everyone for attending today's session. Hope you all liked it. See you all next time.
Okay, guys, so I'm forwarding a link which is for the feedback form. I request you to please fill it wisely.
And if anyone wants to speak about something or wants to have, some more workshops of something, some other topics, you can write it on chat or you can even unmute yourself and talk because we have 10 minutes more. So we can talk, we can interact more about anything related to bioinformatics or biotech and whatever you want to talk about. Yes, Neeraj, please unmute yourself and please talk.
Thank you so much, ma'am. I really appreciate you are conducting really nice, interactive, and quite informative workshops. I would like to request not everyone is IT professional or may not be having good exposure towards the computer segments in terms of languages, because I'm from a biology area and I'm pharmacist basically. However, these days, integration of various sciences are really important, and inevitably, the mathematics plus computer sciences are really an integral part of the biology science also. So, I humbly request if you could please conduct some sort of good individual or combined courses or workshop, hands-on learning. It's not just to show that what you know; it's just to train people if you could that all the languages, like there are many languages which you we can learn, and these days not only for statistics purposes but for research skill development, not only R, Python, and all these other languages. If you could please plan some good program like workshops or hands-on training, it would be grateful. That's all I need to request to you if you have. Thank you so much.
Thank you, Neeraj, for your suggestion. Basically, these workshops, like we have some kind of time foundations. We have some kind of time limitations. I know every one of us wants to learn a lot of things. Even I am from biology background, but sometimes just due to the time constraints, we are not able to give you hands-on and complete training. But for complete training, we have specific courses. Like if you go on our website, if you want to learn a particular programming language completely, you can just click on it and just let us, or you can just mail us or let us know that you want to be in it. So because we will be starting with our programming workshop soon, which will be 7 to 8 days workshop. We will be starting with Python workshop also, again 7 to 8 days, from where, we'll not be telling you what we know, we'll be letting you learn each and everything from basics. Like today you have learned about list, vectors, etc., etc., and we will be taking that to the further level by which ma'am was able to create various charts and everything by giving you assignments so that you also learn and gain some knowledge. This was a kind of overview where you get to know about, okay, these things are actually possible in research also, in IT side also. So we will be conducting the workshops and you will be getting the message and the mail about the same. So just stay there in the Telegram group. That is the only request. That's all. Again, guys, just a reminder that whosoever is from biotech background or from agriculture background, they really need not to be afraid of bioinformatics or any programming language, because we will be conducting on this 10th of January a workshop for the from basics to advanced about the bioinformatics, and you will get to know about various languages used. We will not be providing you hands-on, but you will be getting know the complete overview, and then you can decide in which particular field you wish to go if you're a master student. And if you're a bachelor student, then you can also decide that do you want to opt for bioinformatics in masters or in your PhD. So do attend that workshop, please. Thank you.
Hello everyone, this is Tanay from LifeGen Bio. Thank you for joining in with us. I hope despite of the Monday blues, you were able to enjoy our session. And I request you to please visit our website and give it a shot, browse it a while. If you have any doubts, you may contact me over WhatsApp. You have my number. You may contact me over Telegram. You are free. Please feel free to reach out to me in any form. Okay, and stay in the Telegram group. That's it, so that you can avail additional offers, which probably new customers won't get. Okay, so stay safe. A very happy new year, and see you in the next workshops. Thank you. So I'm ending the session.